Good afternoon and welcome to Material Witness. We thought it would be good to write some actual code using some of the new material design APIs and talk about how we did it and also, more interestingly, how some of the stuff works under the covers.
Yeah, so just one little caveat. Chet just mentioned writing code, and since we're both managers now, we don't really write code anymore for a living, so forgive us if the code is weird.
We should have people to write this for us. I don't know if you know who we are. I am Chet Haase. I'm on the Android UI Toolkit team. I don't know who this is.
I'm Romain. I used to be on the Android UI Toolkit until... Thank you.
Are they...
Until Chet decided he wanted my job, and so now I'm working on robots.
Are they clapping because you used to be on the team?
I think so.
Or because you're gone, yeah.
Like, gee, he's finally gone.
Moving on. Oh, those awkward protesters. All right, let's take a look at a couple of demos. So I had an idea for a demo application that we're going to do together. It was going to go out to Flickr. It was going to fetch these images by Romain. We'd get these beautiful images downloading in the background, and then we'd install them in wallpaper, and it would be all lovely. And Romain was like, I don't have time to do all that. How about if we just hack some demos to show the pieces that we actually care about? So that's what we did.
So we will pretend, we have two demos. We will pretend that we have two demos to keep each demo simple so that the code will be easier to understand. But it's really because we didn't have time to merge the two demos.
So I have a very simple demo showing off some of the things we're going to talk about today. I tend to look at my demos as simple things that I can write code for that clearly explain the simple bits that I want to help people understand. And then Romain writes something similar and actually makes it look good, which is really embarrassing. So here's my simple demo. This is showing some of the elements we're going to talk about in terms of animations and cards and some interactivity as you touch these things, some ripples, so we can sort of see some of this in action. Then this stuff is going to be demonstrated in videos as we go, so we can look a little bit closer. So we see a transition. We're sharing a hero element between these activities. We can change and customize the transition and make the elements explode out and move out to the top and bottom in a staggered way instead. OK, so that's my simple demo.
And this is the second demo, so similar idea with images. So we are going to see transitions, reveals, with a live map view. This has nothing to do with material design. It just looks cool. And if we have time, we'll talk about it. If you look at the colors of the UI, you're going to notice that the colors are actually coming from the images themselves. So this is dynamic theming of the app, basically, based on colors we live from the images. And again, we're going to look at the APIs to do this.
So if we can switch back to the slides. So first of all, let's talk about cards, one of the simple elements that you saw in both of those demos. And the cards are the idea. You see it in a lot of the mocks from the design team as they're talking about material design, setting apart the content into these items that are then sitting on top of these cards, this paper representation, elevated a bit off the view hierarchy plane, so they're casting a little bit of shadow. There's padding around the edges, sort of a nice way to separate the content with some nice white space in there. So we implemented that. In my demo, I did it very manually. I just have a group to sort of do all the little bits and pieces that need to be done. You can also use card view in the support library to do this a little more automatically. So in the case of my demo, there's a round rect shape drawable that I use as a background, and then I clip to that outline. And this is one of the new APIs and capabilities exposed in the L release. So you can clip and get the nice rounded corner there. This is also the shape that is used by the shadow that is then cast onto the view hierarchy plane. So as you elevate this view, then we cast a shadow using the outline that you've told us your view has. So we get the nice rounded shadow, soft shadow effects around the edges of the cards.
And we're going to talk in more details about how elevation works in a few minutes.
So here's how I happen to do it in my codes. In general, views, drawables know what shape they are. So if you have a shape drawable, it knows what outline it exposes, and it can propagate that information to the view. So in general, views should know what shadow the shape should be drawn with or potentially clipped to. Some of that stuff is not yet enabled in the preview L release. So I'm doing it more manually here. the outlines are specified in the coordinate system of the views themselves. So when the view changes size, you need to then update the size of the outline appropriately. So here we override on size changed. We get the size of the view. We create the round rect. We set the outline to shape. And then we tell it to also clip to that shape as well.
And in particular, this trick of creating the outline programmatically in on size changed is very important if your background is a bitmap. Because given the way shadows work right now, the system is not able to generate shadows for bitmap. So if your bitmap contains a circle, the system doesn't know there's a circle. So you have to tell the framework that you want a circle for the shadow.
So a lot of the canonical cases are going to be solved for you if you have a shape. It's going to know what shape to draw that shadow at. But not necessarily all the cases, so it's good to know how to actually do it programmatically as well. And then finally, we set a shadow on the card simply by boosting it up to some value. So we've set an elevation value of 5 here. And as Romain said, we're going to talk more about shadows and elevation later. So you could also just use card view. I didn't happen to, frankly, because it wasn't online when I was writing some of the bits of the demo here, but you could use card view to do this. What I did is actually really simple. The advantage of using card view is twofold. One is that it standardizes your cards with other people that happen to be using that element, so things look a little more consistent across the platform in general. But also, in the card view widget, which is in the support library, when you're sitting on top of the L release, it's going to do the correct thing. It's going to give it an elevation. It's going to clip to the edges. It's going to do all the L correct things. When it's on a previous release, it generates images that look pretty much the same. It's a very good and consistent look. But it's not necessarily using, it's certainly not using the same capabilities because we didn't have shadows prior to this release. But it at least uses these elements of the different releases to give you a consistent look for your application across releases. And you can see here there's examples of card view previous to L and in the L release, and they look pretty similar, and that's a good thing. So how it works is basically if you're running on one of these previous releases, it generates a PNG file with a shadow baked in, just as you probably would with your assets if you were trying to do something on your own. You can use path clipping if you want to actually clip shapes to a path. It tends to be very expensive, so we don't recommend it as a general solution. If we're actually redrawing your views that are path clipped all the time, you're wasting a lot of performance that you would probably be rather be spending on other things in the system as well. There's also approaches where you can use bitmap shader to draw and get a similar result. This is the effect used in, I think, search in KitKat. Yeah. When they did a circular reveal, they were using a bitmap shader to get that effect. Again, kind of expensive. You don't want it running full time on the system, but it's OK for a transient effect. In L, it's much simpler. We can actually tell it the outline to clip to and the outline to shadow to, and we can set the elevation to shadow appropriately. I didn't want to put the actual APIs for outlines on here because this is one of the areas that's probably going to be tweaked a little bit in the final release of L. There's a simple way of dealing with outlines right now. That simple way of dealing with outlines is probably going to change to a different simple way of dealing with outlines. So don't get too hung up on the details since it's a preview release. But the general ideas will be the same. Now let's talk about ripples. This is touch feedback. One of the important elements, we talked about this in earlier talks, was to give the user immediate feedback of what's going on in the system. So we have touch feedback on all the standard widgets so that the user knows what they pressed and where they pressed, and we animate the state change over time. And actually, you probably went to the earlier talk anyway, so I'm going to blow through some of that stuff and get to the more interesting bits of how this stuff actually works. So Ripple Drawable, it's the new class. You can use it directly. There's other ways that you can opt into this behavior, and the standard widgets have it built in. So you can see the ripple behavior here. Is that coming across on the screen? I think so. And then if you stare at it long enough, maybe you'll have a seizure. And here's some of the code to enable some of this stuff. So from XML, you can create this ripple drawable. So you can optionally set a color for your ripple. And it basically uses that optional color and reveals the content that the ripple is actually wrapping. So in this case, we have a drawable that's simply a color drawable. And that's going to be revealed over time with the ripple that's then wrapping that item. Or similarly, from code, you can create the ripple drawable class, optionally set a color on it. Or the easiest way to do it is actually just to set a selectable item background. And that means when the user presses on that, puts it in a selected state, then it's automatically going to run a ripple. The ripple that we saw in the seizure slide and the previous slide uses that approach. It says, I want my foreground to be this ripple drawable. So then as the item is selected, it automatically emanates that ripple on top of it.
And this is the same exact effect in the second demo. We just wanted to show it to you because here the ripple is pinkish purple. The color comes from the theme. So if you use the foreground technique that Chet just showed you on the previous slide, you're automatically going to get the ripples with the right color from your theme.
So how they work in general, they wrap the content. So you can think of it as a wrapper around the actual content that you're going to reveal. And it's going to reveal that by emanating the ripple out from what we call the hotspot, the center point of the interaction. If you use selectable item backgrounds, we automatically know where that hotspot is. We know where the user's finger pressed, and we can emanate from that center point. If you're doing it more programmatically, you can set the hotspot, you can set the XY location in the local coordinate system of the view, and that's where the ripple will emanate from. The other interesting detail is about the render threads. This came up in one of the sessions yesterday. This is a performance optimization that we've enabled in this preview release and we'll be continuing to work on, where the drawing system usually consists of, or has always consisted of, in the hardware accelerated model, we create display lists on the UI toolkit thread, and then we issue or execute the display lists also on the UI toolkit thread. And that's when we actually talk to the GPU and send down OpenGL commands. What we've done is broken those out into two separate threads so that we create the display list on the UI toolkit thread, and then the render thread actually talks to the GPU. If that's all we did, it doesn't really bias anything because we still have to create it before we execute it. But now that we've been able to break this out into separate threads, what we can do is start sending over animations as atomic objects to be executed wholly on that other thread. And the first one of those that we're working with is the ripple. So you'll notice if you press on a button that launches some activity, what you would have seen in previous releases is the ripple would stop emanating as soon as you started the new activity because the same toolkit thread is being used to inflate the new activity as is being used to animate the ripple. So what's happening now is we're sending in information about the ripple animation down to the render thread, and that is able to continue running while the toolkit thread is busy inflating the new activity. So that's the main thing that's executing on the render thread right now. Expect more over time as we're able to do this. There's some really tricky details about what we can run on either thread and what the contract with some of the animation APIs are. But we'll do what we can to take advantage of this new performance optimization. Now let's talk about shadows. I'm going on and on, but trust me, he's going to talk for a lot after I'm done. Shadows are the idea of boosting views in 3D, raising them above what is essentially the z=0 plane of the view hierarchy. One important detail here is that we're using orthographic projection. So typically, if we had full-on perspective camera world, then as you raise things up, they would also scale up because you get perspective foreshortening. They would get larger as they came closer to the view. That's not the projection system that we're using right now due to some of the details about how we want the UIs to actually interact right now. So as views raise up, they are raising in Z and the shadows are expanding, but they're not actually scaling. Sometimes you actually do want the effect of scaling, in which case you should actually animate the scale X and scale Y property to the view at the same time to get that effect that you're looking for. We also added APIs not just to view for the properties around elevation, but also to view property animators so that you can easily animate these properties. So this question came up a couple of times in a previous session. There's a little bit of confusion about what's an elevation and what's translation Z and what Z is. These map exactly to the existing layout and post-layout properties for X and Y. So if you imagine there's the left property, which is the layout property that says where you're going to position this thing in X when layout runs. And then there's translation X, which is a post-layout property, which you usually use for animations, which is additive on top of that left property. And then there's an X property, which is the sum of those. So it's exactly the same thing in Z. Elevation is basically the permanent location that you want that thing to live at. Translation Z is a kind of a post-layout, if you will, property that is then additive on top of that. This is going to be used for animations, like if you go into a press state and out of it, then you would probably animate translation Z, which is going to be on top of the elevation parameter. Or you can simply use Z directly, which is additive. It's the combination of elevation plus translation Z. So here's a simple bit of code that I have in my demo, when I pressed on one of those thumbnail images, it raised up under my finger, and then it went back down, and then launched the new activity when it was back down on the view hierarchy plane. The way I did that was simply through an easy touch listener. When I pressed down on it, I would start an animation that scaled in X and Y, because I did want kind of a perspective scaling effect on that. And I would also animate translation Z. When I let go, I get a cancel or an up, then it would simply animate back down to Z equals 0. Or elevation equals 0, or in this case, translation Z equals 0, and then it would launch the new activity from there. Fairly straightforward. There's other ways to accomplish this, which we'll see later in other code.
Yeah, and I want to talk a little bit about how the shadows are actually implemented. So this is what the UI designers wanted us to implement. So this is an image I rendered in Blender, and it took 10 minutes on my laptop. So
10,
of course,
10 minutes.
Yes.
10 minutes. 10 times 60 seconds times 60 frames a second. Yeah.
So not possible on a phone, but I tried anyway, you'll see. So let's see what we have here. So there's an area light, and Chet mentioned that in the previous session. The area light is what gives us those nice soft shadows that you see at the bottom. So your occluder is the view, and the area light will cast those nice soft shadows. Now, if we implement shadows in a naive way, you would get something like this, where the umbra, so the umbra is the part of the shadow that's from which you cannot see the light at all, so it's fully in the shadows. And then there's the penumbra, this is the soft edges. So that's what, when we talk about soft shadows, it's just shadows that have an umbra and a penumbra. The problem here is you can see that the shadow is completely dark, and in real life this doesn't really happen, because what happens in real life is that the light bounces around. If you lock yourself in a room and you close the door, after a few minutes you will be able to see things, and the reason is light will go through small holes in the door and just bounce around until it hits your eyes. So really what the effect that the UI designer wanted was this. And this phenomenon is called global illumination. So if you look here, you can see that the shadow is not completely dark. It's a little hard to see on screen, but the color of the view itself, the occluder, the red, is reflected onto the ground. So part of the ground is a little bit red, and the ground itself is light. So to implement this, just before I left the Android team, I wrote the first prototype of soft shadows, and this is what I came up with. It was using ray tracing on the GPU, and it looks pretty good. There's global illumination approximation. This looks fairly similar to what you get in Blender or any expensive 3D rendering package. The only default, the only issue with that approach is that it was running so much code on the GPU that after a few seconds, like 30 seconds, the Nexus 4 would overheat and reboot. It was just trying to not melt.
So we fired him.
So I got fired. So we decided that maybe this was not the right way to do it. So smarter people than me found a different approach. So basically what happens is the system will calculate geometry. It will generate a bunch of triangles to send to the GPU that will represent the shadow. And there are actually two shadows in that system. There's the shadow that's generated by the area light itself. So it just projects the area light through the shape of your view, through the outline. And that would normally, and if you just did that, you would get that really dark shadow that we saw before. So the first trick is to make that shadow semi-translucent. So that simulates global illumination a little bit. The second trick, and it's actually a really nice trick, is to have a second shadow. The idea is that because the light is bouncing around, really the world around you is acting as a light source. So we're casting a second shadow as if the entire world around your device was a light source. This is called the ambient shadow, and it's done a little differently. It just projects your view like straight onto the ground as a secondary translucent shadow. The effect is really subtle, but when it's missing, it doesn't look nearly as good. So this is not grounded in reality. This is not how light works in real life. But as always with graphics, what matters is that it looks good. How it's done doesn't really matter. So like I said, the system computes geometry. So every time you move the view in X, Y, or Z, so if you change the elevation, because the light source itself has a fixed position, the geometry has to be recomputed. The nice thing is most of the work is done by the GPU. We just interpolate colors. So this will show you what the geometry looks like. So this screenshot is taken from another prototype that actually runs on desktops that was implemented just to play with different algorithms. So you have your nice soft shadow, you have your view that's tilted in 3D space. And this is the kind of geometry that the system will actually generate to draw the shadow. So here you're seeing only one of the two shadows I mentioned. And the geometry that's being used is not necessarily the same geometry that's used on the device or that will be used in the final release. But this gives you an idea of how it works. Just one tip when you use the shadows. By default, views have a pivot point in their center that's used to apply rotations. So if you rotate your view on the x-axis or the y-axis, and you leave the default pivot point, your view will intersect with the ground. So visually, like on screen, because it's not a real 3D system, you won't see your view being clipped by the ground because there's actually no real ground at z equals 0. But the shadow system will think the ground is intersecting with your view, and you're going to get a bunch of artifacts. So if you want to apply 3D rotations to your view, make sure that you set an elevation that's high enough that when you rotate the view, it doesn't intersect, it doesn't collide with the view hierarchy plane. You can compute it in it's simple trigonometry, or you can just play with values until it looks good.
This is an important point. It's easy to misconstrue what we've done as, hey, now we have a full-on 3D modeling system. No, what we've done is used a z value to get physically correct information about the view system and shadows as we boost these things into Z, but we don't have a Z buffer. It's not a modeling system. You can't use this as a full-on 3D system for doing games where objects can be self-intersecting and you actually get the correct visual results. It's still a fast 2D rendering system that we've added some Z to. But if you're doing things like these, you're going to run into the edges of that system pretty quickly.
Something else that you should be aware of, if you have several views that are stacked on top of each other, and some of these views are rotated in 3D space, so you use an X or Y rotation, the shadows that are projected by the views above will not be reprojected on those views. So the projection of the shadow is always meant for the ground plane. So the shadows will draw on top of the various cards in your stack, but they won't be applied to the transform planes of those different views. So don't hesitate to play with the 3D rotations. I mean, you can create really nice effects. And Chet, in a previous session this morning, showed like a little tilt animation when you drag a card, and it looks fantastic. Just be aware of this very small limitations. So the shadows, so far we've shown them mostly static. And in Chet's demo, I don't know if you've noticed, we're going to get back to it, the shadows are actually animated. And there are various ways of doing it. It's very useful when you want to create a press state, like an animated press state. So you press on the button, and it feels like the button is raising in 3D space. And there are a couple of ways of doing that. So you can see here, it might be difficult to see on screen, but if you look at the button on the right, when the finger presses the button, you'll see that the shadow grows a little bit. It's actually even harder to see on your own device because your finger is on top of it, but it still looks really cool. And this is how it's done. So you can use a simple state list animator. So this is the button that we just saw in the video is a simple image button. You specify a state list animator. It's a resource that lives in the anim directory. And that resource looks like this. If you used selector drawables before, if you've created custom drawables for buttons, this looks very familiar. The difference is that inside the items of the selector, instead of putting drawables, you just put object animators. So here what we're doing in the first item, we say, when the state is pressed, I want you to animate from a certain elevation to another elevation. And when at the bottom the state is not pressed, I want you to animate the other way. And that's all you have to do. It's a very, very easy way to create those nice secondary animations in your UI. And of course, you could animate any property. The only trick is that from XML, you have to tell the system the type of property you want to animate. It won't be able to figure out that the elevation, the translation Z here is a float. So this is how you would use the state list animators from code. It's easier to do it from XML, but if you want to dynamically load those animations, this is a pattern that you're probably familiar with.
So one of the big new animation capabilities that we enable in the platform is activity transitions, in particular the ability to share elements between separate activities, which before you could do, but it's a little tricky to figure out how it works. We created a dev byte showing how you can do it, so you could certainly take that approach on previous releases. But now we've taken the new transition API that was new in KitKat, and we basically baked that into the ability to have much more rich animations between activities. So now you can think of these 3 separate phases of these activity transitions where we have an animation that's happening in the activity that's going away, where we can animate the items out. And we have items in the new activity that are going to be animating in. And in the meantime, we're passing information about a shared element between these activities so that we can then animate that item to some state in the launching activity and then animate it from that state into its final position in the launched activity. So sort of all these different separate bits, all of which can be customized to whatever extent you want. And the information that we pass about that shared element is the position of that element, the size of that element, and a bitmap that represents that element, as well as the name. And then if the launched activity knows something associated with that, so if you're in a music app and you see a list of albums and then you go into a detail view and you pass over a shared element with the name album, then the launched activity can say, oh, I know where to put an album on this screen. Sure, I'll take that element. Then it's in control of the transition and can animate it appropriately. There's also the ability to customize these transitions, and that's customization in terms of the actual transitions you run. So you can have different kinds of effects. Right here, we see two different transitions happening. This one is an explode. You can see the items animating out to the top and the bottom. And then we toggle that checkbox on top, and we get a crossfade, the default crossfade transition instead. So you can customize things with either the transitions that we ship with a platform or transitions that you write on your own. You can also customize it in terms of which transitions target which items in the UI. So you can say, I want fades to happen on these targets. I want explodes to happen on these other items. And you get a much more choreographed experience as you go from activity to activity. So here's some of the code that you would need to use in enabling the basics. There's a lot more code, a lot more APIs that I won't go into the details of. First of all, right now you need to be using the material theme on the preview release. That requirement may go away. It seems like we should just enable activity transitions in general if you want them. But right now you enable the material theme, and then you would say, I want to use window content transitions. You can either do this in your theme itself, or you can specify this in code by calling the request feature method. And then you can set some optional behaviors. So once you enable transitions, you're going to get some default behavior. It's just going to crossfade between your activities by fading the items in and out as you go between activities. But you can set up custom animations. Here we're going to use an explode on the exit transition. So as I leave my activity, items are going to stagger and animate out to the top and the bottom. You can also specify the overlap behavior. By default, we're going to overlap the animations of the enter and the exit at the same time, or as overlapped as they can be, depending on how long it takes the launched activity to actually inflate and get ready to go. Or if you want to choreograph it more carefully and say, no, I want this animation to finish first, then you can set the overlap property to be false instead. And then you can set up information about shared elements. This one sets up a single element and assigns a name to it. You can also have a set of elements. You're basically passing this map down and saying, this item is going to be used with this name, and then the launched activity gets all that information on the other side. And then you start the activity with that information, and away it goes. So how they work is basically building on the transition capability that we had in KitKat. The big idea with transitions is I want to know where things are at now, and then I want to run layout and figure out where things are at afterwards. And then I want to start the animation based on where things were and then animate them to where they are. It's the same idea, except that was in a single view hierarchy in an activity, but this is applied across activities instead. And it's applied in the following way. We know what's happening to the items in the launched activity. So in the explodes case for a transition, we're going to move all the items out. So we're going to say, OK, I know where everything is now, and I know where everything is when it's animated out. We're going to run that animation. And same thing for the launched activity. We know where things are off screen. We can animate them on screen, all using transitions. And then the final element is the hero element. So once the launched activity gets the information about the elements that you want to share, it says, oh, I know where to put the album on the screen, and I know what size I want it to have, and I know what size and position it had where it started. So I'm going to run a transition that automatically animates those changes over time as well.
So sometimes the default automated transitions are not enough for some types of effects. When you use one of those automated transitions, the framework will look at some specific properties of views, like size, position, alpha, but it doesn't know about all the properties that you can use in the UI toolkit. So here's an example. In the list of thumbnails, you can see that the thumbnails are darkened. So I use the color filter on the image views to darken the thumbnail. So what I want to do is when we transition to the new activity, I want to animate that color filter from dark to clear. And because the automated transition system does not know how to do that, we need to synchronize with that system to run normal view animations when the transition is done. This is actually fairly easy to do. So to run an animation after a transition, you can just get the enter transition from your onCreate method in your activity. You can add a listener. And we just listen for on transition end. So at the end of the transition, I just run my custom animations. So in this case, I just I do the color filter that I'm not showing in the code because it's a little more complicated. I also fade in a couple buttons. It's also important to remove the listener when you're done using it. You also want, if we go back to the video, you can see that when we go back to the list of thumbnails, we will want to, if the video plays. Okay, when we go back to the list of thumbnails, we want to redarken the image, and of course it's not in the video, sorry about that. So you want to be able to run custom animations before the transition. And an easy way to do this is to override on back pressed. You run your normal view animations, you listen for the end of those animations, and at the end you just call this finish after transition method. You used to call finish, but if you call finish after transition, we're gonna run the transitions and then finish the activity. Just be careful if you implement those techniques. The code is a little bit more complicated if you want to deal with the screen rotation correctly. Because if you rely on those listeners, when you rotate the screen, there won't be a transition, and so your animations won't run. So you probably need to set something in your bundle, in your save state, and take a different action based on that. I mentioned animating a color filter. That's a technique we've showed in presentations in the past. It was a little painful before because on every frame, you would have to create a new color filter instance to create your animation. That was generating garbage. That was causing GC pauses. So sometimes you would get a stutter in the animation just because of the extra garbage that was generated. So as of the L preview, you can animate color filters without recreating them on every frame. There's a new set color method. So here we use an object animator, and we animate the color property of the filter directly. The only trick here is that a color filter knows nothing about the view it's associated with. So just changing the properties of the color filter will not change what's drawn on screen. You need to trigger a redraw of the view that uses the color filter. So an easy way to do that, you can see here, is to add an update listener. And on every frame, you set the color filter again on the drawable of the view that you want to animate. And then everything will redraw properly.
So one of the new elements in the preview release is reliance on and more flexibility with colors in general. The assets that we have by default are all grayscale, and this is done on purpose so that it's easier to then tint those as required by your application or by different states of your application or by different activities within it, so that it's easier to brand your application the way that you want, and also to produce less assets. So previously, if you wanted to colorize your application, you could certainly do that by creating images with that color. What we'd like you to do instead is to actually use these neutral colors and then tint them as appropriate to whatever that situation is. So much easier, much more powerful, much more flexible. And one of the elements that's going to make that easier is a new utility in the support library, which is the palette utility, which allows you to then go out. There's another reliance on images as well. You've seen a lot of images in a lot of the material design content so far. Wouldn't it be nice if you could actually figure out information, color information about those images, and then use that information to then colorize your UI, as we saw in Romain's demo so far? So I already explained this, so I'm going to just go on to your stuff. It's more interesting.
So first I will show you how to change the colors of the static theme. So that was the first activity in the demo I showed you. So it uses pink for the action bar, the status bar, and the nav bar. So it was also using purple for the ripples. And this is how it's done. So you create a new theme. You inherit from theme.material or theme.material.light. And there are 5 colors you can override. You can see them here. We have color primary dark, color background, color accent, and color control highlight. And the system will by default use those properties to colorize the theme. So I colorize the different values based on the actual RGB values. You can see, for instance, the color accent and the color control highlight are purple, and that's where the purple in the ripples was coming from, so entirely from the theme. You can see next that I've also colorized the navigation bar, the nav bar at the bottom, and the status bar. So I just use references to reuse the primary dark color from my theme, and I've also changed the background color to one of the colors from my theme. So it's very easy very simple to do, and certainly beats like creating dozens or hundreds of assets just to change the default color to like green. Now to generate those different secondary activities that have, all the colors are coming from images, things are a little bit more difficult. There's a new API that Chet mentioned called Palette. It comes with the new support library. So the jar file is android-support-v7-palette. And what it does is you give it a bitmap, and it will generate a series of colors from that bitmap. So by default, it will try to generate 16 colors. You can specify how many colors you want. It will also try to give you 6 named colors, and you'll see what I mean by named colors. You just have to be careful, because those named colors can be null. So if you pass the Palette API like an image that only contains blue, it won't be able to generate those 6 colors for you. So you might have to use fallback colors in your application. So this is an example of the output of Palette. So given that image on the left, you can see the named colors. So they're called dark muted, vibrant, light muted, and light vibrant. And on the right, you can see the full palette. So I think it generated something like, I don't know, do the math, 15 colors or something from that image.
14.
14?
That's 14.
Okay.
I got a math.
That's why I was fired. This is how you use that Palette API. It's super simple. You call palette.generate. You give it a bitmap. Optionally, you could give the number of colors you want. There's an asynchronous version of Palette. So if you give it large images, it's going to take a fair amount of time to generate the palette, because it has to look at all the pixels in the image. So there's a callback system so that you can do something else while you're waiting for the palette to come back. And this is just an example of how you would apply programmatically the colors to your UI. So for instance, I changed here the background drawable. I use the dark muted color. So notice that on the palette, when you get a color, you actually get a palette item. You don't get a color directly. So that object can be null. And if it's not null, you can call get RGB to get the RGB color for that item. This is a slightly more involved example. So here, all my buttons used ripples, and the ripples and the background of the buttons is the colors come from the palette as well. And here's how you do it. So this is the ripple drawable that I was using from XML. So a ripple drawable is basically a layer drawable. So it can contain a number of other drawables. So here I only have a circle inside, so that gives me that nice round background. And don't look at the color. The colors are here just so that the XML can be compiled. I override those colors from code. And this is how they are overridden. So I have a background color and a tint color that come from my palette. You can call set color on the ripple drawable to change the color of the ripples themselves. But if you want to change the color of the circle, the actual background of the button, since that background is a layer in the ripple drawable, you first have to call getDrawable 0, because I only have one item in that list, and then I can set my tint color on that second drawable. Reveal, you've seen that animation earlier. We'll show it again. So this is a new animation that you're going to probably see in a lot of applications that implement the material theme. It's just a circular shape animation that's used to reveal any kind of content. So in L, it's super easy. You just call view animation utils that create circular reveal. And if you want to implement that in prior releases, there are techniques. So it's mostly using textured shapes and bitmap shaders. I wrote an article on my blog that explains how to do it. It's fairly easy, but that means the view itself cannot be dynamic. You cannot change the content of the view during the animation. So this is what the circular reveal looks like. When we press the little button in the bottom right, we just reveal a map view. So this is a fully dynamic map view. That's not an image. It's the actual map view running OpenGIS, and get me 13 in 3D rotated and moved. So the good news about the implementation in L for circular reveal is because the framework is aware of those animations, it's using a new implementation that's shader-based. So it's much more efficient compared to the way you could do it in previous releases. So Chet mentioned that again in a previous session. So you could use the stencil buffer on the GPU if you clip with a path that's extremely expensive. You shouldn't do it. It's also using more memory. It was not anti-aliased. The new solution is, it's still a bit slower than if you are not using a clip or if you're not using a circular reveal, but it's fairly efficient, and it doesn't use memory at all. Just know that there's a slight limitation in the L preview. The circular reveal is not anti-aliased at the moment, and it should be fixed for the final release. This is what the code looks like. So we call create circular reveal to reveal our map view, and you have to pass 4 parameters: the center of the origin of the reveal of the circle animation, the start radius, and the final radius. So here it's pretty easy to do because my button was sitting on top of the map view, so I can just get the coordinates of the button and use that as the center of the reveal. If the view from which the reveal is originating from is not a child of the view you're revealing, you might have to do a bit of math to convert the coordinate systems, but it's fairly simple. And similarly, when you want to hide the map view, you just swap the radius. So you go from the full circle down to 0, and it's going to do the animation correctly. And we have 5 minutes. So we're going to take questions instead of finishing the presentation. So again, that has nothing to do with material design. This is just a cool effect that you can implement all the way back to API level 1. So this is what it looks like. I wrote a full article online using a different demo. So if you want to know how to do that kind of cool visual effects, you can go read it. And we're going to switch to Q&A. Blah, blah. Q&A.
Q&A, and that's it. Thank you.
And if you have a question, please walk to the mics. Yeah. No questions.
No running.
Man, we're so good that
running.
they understand everything.
All right. Yeah, it's all straightforward. Very easy. Great. Yes.
Memory. How does it deal with memory? I mean, we're already dealing with images. We're already running into memory constraints all over the place, right? So.
Which element are you talking about in particular?
Well, all these animations and so on. I mean, shadows and.
Shadows. So the stuff that we're showing doesn't really put any memory constraints on. We are certainly creating a mesh for the geometry for shadows, but this is trivial in terms of the amount taken up by bitmaps. That's basically just a bunch of vertices that we're going to send down to the GPU and then shader commands. The image effects that we're showing, I mean, obviously if you're using more images, you're using more memory for those images. But the actual animations that we're talking about, not so much. They're kind of data structures. Not really an issue. In the back.
I have a question regarding the selectors with the object animators.
Yes.
So you specify a start and an end values. Is there a way that you can say that the start value of let's say you have a press state and then a normal state, that the animation to return to normal can use the current value?
Yes. In fact, that is the way that it's supposed to work. There is a bug in the preview release where that is not the way it actually works. And so currently in the preview release, you have to give it a start value. That bug should be fixed in the final release.
OK, thank you.
Yep.
Somewhat related to that, just as far as overlapping reveal transitions, does one stop and another take over, or are they able to run at the same time?
So I do not know the answer to that.
Okay. Thank you.
Chet, tell us.
I'm thinking if it's on the same view, there might be a conflict. There's nothing to stop you from running different reveals on different views. But yeah, the same view, I'd have to think about that. Let us know what happens. In the back, there's nobody, so go.
For colorizing, is there going to be a non-XML programmatic solution for that?
Yes, Chet, what about it?
Programmatic access
I say yes.
To theme attributes. The person that is working on that is nodding. So either yes or he's falling asleep. Thank you. Or it was a slow nod. It was not a seizure nod. Yeah.
So you mentioned that when you run palette on large images, that it's slow.
Well, it's not that it's slow. It's that
slower.
The larger the image, the slower.
Is there a sweet spot? It seems to me you could shrink the image and still get the same colors.
I was thinking the same thing as he was saying that.
Okay.
Yeah.
Is there, if there's some sweet spot to, we can shrink it, and it probably depends on the image. But
the problem is that it really depends on the image.
Okay.
And by default, I looked at the source code of the palette API, and I don't remember it doing any scaling whatsoever. But that's kind of a good thing, because that means you can do it if you know the content of your images. I mean, if they're low frequency, you can certainly scale them down. But if you have high frequency images, you might lose, some of the important colors.
Cool.
So this question's about the activity transitions. So when we're transitioning between activities and we're sharing a view, the view in the destination activity I guess. What happens if it's like a heavier view, like a map view? Are you able to like if it's not able to initialize in the time that the animation is happening? Is there a way to deal with that?
There's definitely some tricky bits to this interaction. So it's best to view activity transitions as being these bookend animations where you cannot get a seamless animation from one to the other because we really don't know how long the launched activity is going to take to inflate. If it's a really expensive view hierarchy, if it's getting resources from the network, whatever. If it takes 3 seconds to start up, obviously a seamless transition is not going to occur, right? So you'll have to factor that into whatever behavior you want for your animation. But having said that, then you figure out what the choreography should be. In general, you probably want to do something like animate the items out, and then animate your hero elements in the old activity to some sort of standing pattern, right? Just animate it up and have it sit there and wait until it can go in the launched activity.
So we have time for one last question in the back.
I was wondering, since we're going to have a first-class support for path animation, is there going to be any kind of support for decoding SVGs or similar vector formats?
Let's be really clear. His path animation demo was not part of what we were trying to do today. No, so that's I'm not sure where you got the message from, but that was basically a way to animate paths using Android. That wasn't like first-class support in L APIs or anything.
Okay.
Right. So if you go to his blog, you can see how he's doing that on current releases of Android.
And
it has nothing
I
to do
used
with
the
behavior
third-party library to load SVG files.
Yeah, yeah. So
Okay.
you can certainly consume SVG and do stuff with it already. We have a very full and robust path API. All of that stuff is usable, and that's what he was using in his demo.
And we're done. Thank you very much.
Thank you.
All right. Thank you.